Okay, lesson 1.3, property of parent functions. So parent function is the very basic form of the function, okay, without any transformations. We'll be doing transformations later in the chapter. Okay, so we're looking at the very, very basic form. Okay, so the parent function, it says here, the base function in the family, simplest function in the family, and then we have a family which shares common characteristics. So we have in grade 9, you learned about linear equations. So we have a line. If we were to move it up and say the line went through here, okay, then you would have, that would be part of the family. Okay, so it's still a linear function. It just got shifted upwards. So this is the parent function, and this would be part of the family of the function, okay, because it has a transformation. Likewise, for a quadratic, we have a quadratic like this, but we could reflect it and maybe face it downwards. Okay, so this would still be a quadratic. This is the parent function, and this is part of the family. So I put the notes here for the first two, since this is covered in grade 9 and 10, and then this one here is covered in, grade 9 and 10, because you do it in the first unit, and then you learn quadratics in grade 10, and there's a couple units based on that. Okay, so the linear function is just y equals x. Remember, f of x equals y, so y equals x. Okay, and we could transform it, and if we transform it, we have mx plus b. So m changes the steepness of the line, which is your slope, and then b is your shift up or down, which is your y-intercept. Okay, we have a quadratic function. Okay, so again, y equals x squared is the parent function. And then here we have the a, h, and k, which you learned last year, which transform the quadratic so you can stretch or compress it. You can move it left, right, up, or down. But we'll learn later in the chapter that this h value now is turned into a d, and this k becomes a c value. So you'll see with the rest of the equations, later in the chapter, that we no longer use h and k, we'll be using d and c. Okay, so some features here. So a linear line is a straight line. It goes to the origin. The origin represents 0, 0. Okay, the slope is 1. It divides the plane in half. Okay, so it cuts it in half diagonally, and it's in quadrants 1 and 3. Okay, the domain for x, since it for your x's, since it goes through all the positive x's and all through the negative x's, it is xer, and our y values is the same. It has all our positive y values here and all our negative y values. So our range is also yer. Okay, a quadratic creates a shape that's called a parabola. Not a parabola, a parabola. This is the shape, okay? It opens upwards. The vertex is at the origin, so again, it's 0, 0. The parent function has a minimum value, but you learn if we reflect it, we could have a maximum value. The equation, the axis is the y-axis, so the equation, the axis is what cuts it in half. Okay, so it cuts it equally into 2 equal parts, and it's in quadrants 1 and 2. So just to refresh you on the quadrants, this is 1, this is 2, 3, and then 4. So we count counterclockwise for our quadrants. Okay, so let's do our domain and range. So we have all our positive x's, okay, all our positive x's, all our negative x's. So our domain is xer. And this is the case for all quadratics, unless that you learn it for a, let's say it's for a real life question, then usually you have some restrictions. But the y value always has a restriction. So in this case, the lowest point here is where y is equal to 0. Okay, so it's yer such that y is greater than or equal to 0. Okay, because the lowest value is 0, and it's everything above it. Okay, so a couple new functions that we'll learn this year. And I think you'll learn one more in grade 12. So we have the square root function, we have the reciprocal function, and then we have the absolute value function. Okay, so you're familiarized with a square root. Okay, so the values that I use for square roots are fairly easy. Okay, so I would plug in values here that is easy to square root. You could plug any positive value in here if you want to, but I would personally, I prefer ones that are easily to square root. So the lowest one we can square root is 0. If we square root 0, we'll get 0. If we square root, let's say 1, we get 1. Okay, then after that, if you square root 2, you get like 1.4, I think. So we don't want to use 2. So the next number that we could square root nicely is 4. So square root 4, you get 2. And lastly, if we square, the next number would be 9. So if you square root 9, you get the answer of 3. Okay, and then the square root function looks something like this. Okay, so it's going to go up and around. So it's kind of a sideways, kind of half a parabola. And this shape that it makes is called a hyperbola. But sorry, that's for the next one. So it's kind of a sideways parabola. Sometimes you'll notice whenever you square root something, you should get positive and negative values. So you learned in grade 10 that when you do the quadratic formula, we have that plus or minus. So if you remember from last year, the quadratic formula looks like this. So here we have a plus or minus, because whenever you square root a positive number, you actually get two answers. So you get a positive answer and a negative answer. So technically, we should have a positive, negative value for all of these. But for the actual function itself, they don't include the negative values, okay? So you don't need to include the negative values, but sometimes, especially when you get to grade 10, what happens is you have another arm that goes this way if you include the negative values. Okay, so it's kind of like a sideways parabola. We're not going to include this in the parent function, but we'll learn later in the chapter that sometimes we do include this value, and I'll tell you later why or what equation to look out for that will include this second arm here. But for now, the square root function, we're not going to include this arm. Okay, so we have a half parabola that opens right. Okay, we'll notice that it starts at the vertex as well. Sorry, it starts at the origin. At origin, which is 0, 0. We have both restrictions on the x and y. So we have a minimum x value and a minimum y value. So minimum x and y values. And you'll notice that it's only in one quadrant. So quadrant 1. I'm just gonna erase this part for a minute. Okay, so domain and range. So we always start with the XER and the YER. Okay, so our x values, we only have positive x values. We don't have any negative x values because we can't plug any negative values in here because you can't square root a negative. Okay, so we have x values, so it's everything greater than or equal to 0. Okay, so we start at 0 and we go positive, so from 0 and everything above it. And the same for our y values, so this will keep going this way. So you have all your y values that will touch this at one point. So our y values is everything greater than or equal to 0 as well. So this is what I have so far. Okay, so now something new, and which is probably the most difficult one that students find, is called the reciprocal function. Okay, so it's just the x value and you flip it. So if you took this value here, and so this would be over 1. If you were to flip it, you would get 1 over x. Okay, so the reciprocal function, I'm just going to show you what it looks like first. So it looks like this. Okay, so it kind of looks like two, I guess, sideways U's. So it goes along the y-axis, okay, close to it but never touches. and then also comes down towards the x-axis, but never actually touches the x-axis. Same thing in quadrant 3. So it comes this way and it gets close to the x-axis, but never crosses it. And then it comes down this way and approaches the y-axis, but never actually touches the y-axis. Okay, and the reason why is at this point, your x value and y value are 0. So if I were to plug a 0 in this equation, you guys could try this on your calculator, or I'll show you guys. If I could find my calculator. Where my calculator is. Oh, here it is. Okay, so if I were to plug 0 into this, so if I did 1 divided by 0, let's see what your calculator does. So 1 divided by 0. And when you do that, you get an answer, a math error. So we can never, so there is no answer with that. You probably learned that in grade 9 when you're looking at vertical lines, that the answer is the slope is undefined. So this is the same thing here. So we can never, ever, ever have a denominator of 0. And that is important for this, and it's important for later in the course. You have to know that we cannot have a 0 as a denominator because there isn't an answer for it. So we can't use 0. Okay? And so since we can't use 0, we're never going to have a point that crosses the y and x axis. Because if I plug 0 into x, I don't get an answer for y. But I could plug any other value in here. Okay, so how do we graph it? So what I would do here is just take some negative y values and positive y values. So the easy ones are -2, -1, 0, 1, 2. And you can use that pretty much for every equation if you want to. So for a line, you could use -2, -1, 0, 1, 2. For quadratic, same thing, -2, -1, 0, 1, 2. It changes with the quadratic since we can't use, with the square root function since we can't use negatives. So you could do 0, 1, 2, 3 if you want to, but it's just easier to plug in numbers that are easy to square root. Okay, so let's plug these in. So if I plug in a -2, I would get 1 over -2. So mental math, 1 divided by 2 is a half, so 0.5, and it's negative. So we get an answer of -0.5. If you plug in -1 now, we have 1 divided by -1, gives you -1. Okay, 0 we can't use, so there's no answer for 0. And then we continue with 1 and 2. So if I plug in +1, I get 1 divided by +1 is 1. And if I plug in 2, I get 1 divided by 2, which is 0.5. Okay, so on my graph here, if I had -2 and -0.5, it would be somewhere here. Okay, and then -1 and -1. So you'll see the points here. So let's say this was -1, -0.5. Okay, and likewise, if you go upwards, if you have plug in a +1, you'll get +1. If you plug in +2, you get a 0.5. Okay, and as you plug in smaller and smaller values, you get this arm. If you plug in large numbers for x, you'll get this arm here. So the larger number that you put in here, the smaller the decimal is going to be for both positive and negative values. Okay, so this shape is called a hyperbola. Not a hyperbola, but a hyperbola. Okay, note that we do not cross the x or y axis, so it does not intersect x and y axis. Okay, it's in quadrants 1 and 3. Okay, so sorry, I don't know if you'll be able to see that. So it's in quadrants 1 and 3. Okay, so and this is going to be a new term for you guys. So new term. So what happens here is it will not touch the y-axis and it will not touch the x-axis. Okay, so if a graph comes close to but never touches something, we call that an asymptote. Okay, so this line here is going to come very, very close to the x-axis, but it will never touch it. Likewise, this part of the arm of the hyperbola will come very, very close to the y-axis, but it will never touch it. And that happens in quadrant 3 as well. So this arm's going to keep getting smaller and smaller and smaller, but it will never cross the x-axis. And likewise, this one actually keeps getting larger, 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 negative, but it will never touch the y-axis. So if a graph comes close to something but never touches it, it's called an asymptote. Okay? Actually, I don't know if I was supposed to tell you that. So we have the x and y axis are asymptotes. I think we learned it again later in another section. So the x and y axis, axes, are asymptotes. Okay, and if we do the domain and range, okay, this one's a little bit unique. Okay, so we start with XER and YER. Okay, so what happens here, if you look at this graph, we have all our positive x values will hit this graph at some point. Okay, it will hit this graph. Likewise, all our negative values will touch this graph at some point. Okay, so we actually could use all the positive x's and all the negative x's, but we're not going to put that into the domain because it's too long. So you would say it's everything greater than 0 and everything less than 0, but that takes some space. So what we do instead is we just say what it's not. So the only x value that it cannot be is 0. So what we say here is x cannot be equal to 0. Okay, so we put an equal to and a dash through it, means it cannot equal 0. So it's all values of x. So x is an element of real numbers. So it's all x values except x cannot be 0. And this is the same for the y's. Okay, so we have all our positive y's will touch it at the graph at some point. All our negative values of y will touch the graph at some point, but we'll never have y equals 0. So for our range, again, it's all values for y, except for y cannot be equal to 0.